Hello. So in this class today here we will study about the MPLS technology. We will study here that what is this technology, what is the concept and the terminology of this technology here. So MPLS basically refers to your multi-protocol label switching. This is multi-protocol label switching technology. So this is basically a transport technology. Now we have been using here various transport technologies like our IP forwarding is the most common technology here. Then we have been using ATM, PDH, DSL and different kind of technologies here. So this MPLS here is a data carrying technique which is basically used for the high performance in networks like telecommunication network. So this basically here directs the data from one network to another network. So we will see here that how this proves to be a better technology, a new technology and solutions to the various service provider here. So although it's not very new here, but this technology was introduced in 1998 by IETF. IETF, which is your Internet Engineering Task Force. Now, as we can see that here, this MPLS here stands for your multi-protocol label switching. So this includes here two terminologies here, multi-protocol and your label switching. That means the term here itself shows that it can incorporate a number of protocols. That means it doesn't depend here upon the underlying technologies. That means it can aggregate the information or it can pass the data coming from the various technologies. That means the various underlying technologies can be using different kind of protocols. So MPLS doesn't depend on that. So that means it can support here multi protocols. And how it is forwarding the traffic? It is forwarding here the traffic with the help of your switches. It means it uses here the label switching technology. So this LS, which is your label switching, this label switching is the technique of forwarding the traffic by overcoming the problems of your traditional IP switching. Now what happens in our traditional IP switching? We can say that our traditional IP forwarding, that is your traditional IP forwarding in your layer 3. This is a layer 3 system here, your IP forwarding. So that basically includes this is your hop by hop routing here. But in your MPLS, the switching of packets will occur at the data link layer. Now this occurs at your L3, which is your network layer. And in your MPLS, that will occur at your data link layer, and it is based, the switching of packets here is based on your labels. That means we're not using here the IP, we're using switches. This label switching concept, or we can simply say that we are using labels here in our MPLS system. So first of all, we will see that what we had in our previous technologies, like we're using the IP forwarding also, that is used in a greater extent also. So if you just have a look at the traditional IP forwarding. So what happens now in our IP forwarding or our internet protocol system, which is used in our layer 3? So we have various devices here which is used for this transport mechanism. So we have the routers here in our layer 3 for this forwarding mechanism. That means like we have a different number of routers here. So what will happen when a data is to be forwarded through this IP domain? So that will simply enter here, for example, this. So it has to be forwarded like from destination, from source to this destination here. So what will happen? Each of the router which will be falling in the path here, it will perform an IP lookup. It will go through this. So each of this will perform an IP lookup. That means it has to find out that to which next hop it has to forward the data packet. So we can say that our IP forwarding is this forwarding here is based on destination address. So this routing lookups, these lookups here will be performed on every hop. Like from this router to this router, we have one hop. So at this hop, this lookup will be performed again. At this hop, again the lookup will be performed. And then what will happen? The packet will be transferred from, or it will finally reach at its destination. So this hop or this lookup will continue until final destination here is reached. The packet has reached to its final destination. So what happens now? Every router here may require the full internet routing information. Now a particular route, it can have, or it can be like more than this. So that means every time when data is being forwarded using this forwarding technology, it has to find the absolute match here. Only then it can forward the data. So it has to go through this lookup table. We can say that it has to go through the longest subnet mask, find the match. If it is not in that sub network mask, it has to go to another longest network mask. So this is basically time consuming here, and it can lead to congestion in the network also. So this was the drawback here with your traditional IP forwarding here. Now after that, we have also been using the ATM technology, which is your asynchronous transfer mode. So that was basically considered as your like IP over ATM. So which is your asynchronous transfer mode. Now this is also a connection oriented technology. It has also a fast packet switching system, but what it has fixed length of packets, which is basically called cells. So this technology here is complex also and expensive, so it's not deployed at that higher rate, but in comparison to that, the IP technology has been used more as compared to your ATM. So after that, this MPLS here was regarded as the hybrid. That means it will include this packet forwarding from your IP also, and the circuit switching from the ATM system also. So the MPLS, multi-protocol label switching here, is a new forwarding mechanism in which the packets here are forwarded on the basis of labels. That means instead of having different IP address at every router, what it simply has some label, a number like this, on the basis of which it will traverse its path. So if you just have a look here at how it happens or what this label switching is here. So that means you will have different number of packets here. So each packet is assigned a label, and then the switching takes place here. For example, this is a packet. It has some payload with it. So what will happen? For example, this is a label like this is attached to it, and then it will be forwarded to the next device, router here in your system, and then it will be forwarded here one by one until it reaches a destination, but on the basis of labels. So we can say that these labels here, or these may correspond to the IPs. like IPs, like IP used were used here in IP forwarding to forward the traffic. Similarly, we have here labels. Now, this IP forwarding here is your layer 3. That means it is the layer 3 of your OSI model. Now, where does this MPLS fits in our OSI model? So, this MPLS here sits between the layer 3 and the layer 2 of your OSI model, and this is basically referred as a layer 2.5 networking protocol. This is your layer 2.5 networking protocol. Your MPLS. So that means like your layer 2, which is your data link layer, it covers protocols like your Ethernet, SONET, uh, for your local area networks or for your point-to-point wide area networks. Then you have the layer 3, which covers your internet wide addressing using your IP protocol. So MPLS sits between these two layers. So we can say that now if MP multi-protocol, now we can say that here it can carry multiple or many protocol traffic. It means coming from different sources, or we can say different layer here, like it is Ethernet, whether it is using SDH, whether it is using ATM. So it doesn't depend upon the underlying layer. What it does, it simply maps into the various technologies. For example, if you have different technologies here, like your Ethernet, or you have your ATM, or you have your SDH, or your SONET. So what will happen? It will simply map it. The MPLS domain will simply map this. It doesn't depend here upon the underlying layers here. So this is the basic concept, basic definition here for your multi-protocol label switching. So this clarifies here about its multi-protocol advantage. Then in your switching, in your label switching, it's simply what happens here in the switching system or in the switching part here. It simply has a list of input port IDs and packet reference IDs. That means you have a IP packet, you have address, so it will have a reference input port for that and a reference output port for that, so that the incoming packet could be assigned a label and then it could be forwarded through that route or through that path here. So, like in our IP systems, we have the routers are the connecting devices, or we can say that the main component here for your IP network here. Your IP has routers here. Now, your MPLS systems here has LSR, label switched routers or label switching routers, because it is performing here the switching. So these are referred here as label switching or label switch routers. So what are these? These are your provider routers, which is providing the path, which is establishing a path for the transfer of your information, for the transformation of the packets. So these are basically the IP routers, but these are MPLS enhanced. These are your IP routers, but MPLS enhanced, as it has to include this terminology in its function. So this enhancement here is basically done with the software upgradation here. So in your MPLS domain, or we can say that if you just look at the component system here for MPLS, so you will have these routers. Now, at the beginning, to mark the entry of your MPLS domain, you will have here these routers, but here at the entry and the exit, these are called as LERs, and in between these are your LSR. So this is if your MPLS domain. So this is your simple label switch router. We will study each of these components in detail when we will study about the architecture and functioning of MPLS systems. And these LER, when they are at the edge of the network, then they are called as your label edge router. Like this can mark here the entry or the beginning of your MPLS domain, and then it could be like your exit. Like you can say that the traffic here is coming from IP domain. So it will enter here into the MPLS domain, and then it will exit and go to the normal IP domain here. Now what happens in this label switching system here? First of all, what will happen? For example, a packet here arrives. So the first device, what will do here? It will simply do a routing lookup for that. Now, in traditional IP, it will find out the next hop. But here in label switching, it will find the final destination router. The first device here will do a routing lookup, and then what it will do, it will find a final destination router. So that means in your label switching, what it does, it finds a predetermined path for a packet here. So when it finds a path, it will apply a label. For example, it finds a path that this will be the path here for this packet. So it will assign a label here. Then this is basically label is like you're also called here as a shim header. So that is basically the identification here. So that header here exists between the layer 2 and layer 3 header, which we will also discuss later. So it will pass through this, it will go through this LSR, it will check the label. Then the process here is like when it first enters, it pushes a label to a packet. Then it is forwarded. So next LSR will check and then swap. So then it will be forwarded through the network. Here we have only like 2 LSR. We can have a number of label switch routers here. So it will go from one to another. It will swap, give a new label and forward it to next LSR. So when it will reach at the destination, then it will pop that label and then it will be forwarded to the IP domain here. So these routers uses the labels to route the traffic without any additional IP lookups. At final destination, you will simply remove that label here. So we can see this example here in another way also. Like for example, you have this is the IP domain here. Now, before entering to MPLS domain, it should have that header also. So, how that will be done? For example, now the first here we can have with IP domain the simple router here. So that will be here connected to, it will have a connection with your ingress LER. Label edge router. Ingress means that this is the entry point, incoming point here for the packets here. So this is your ingress LER. Then after that you will have your MPLS domain here. So packet arrives from the IP domain where at the ingress LER. So what it will do now, it will be an IP header. It will be coming from L3, from your layer 3 network layer. So what will happen? this LER, the label edge router here, will check the L3 information, that what packet it is, and then it will check the lookup table. So LER here checks L3 information, then it checks the lookup table here, and then finds a reference which is called as your FEC, which is your forwarding equivalence class here. So this forwarding equivalence class basically describes here a set of similar packets which can be forwarded in the same way. Now, for example, here it will have a IP info, and at the second end you will have the label. For example, like this is some IP. So it will check the information, it will check the lookup table, and then find a reference for that class, to which class it belongs, and then assigns a label to it. Now, for example, it assigned a label 17 to it. That means this label is added, pushed to that packet. Now, after that, it will be forwarded to your MPLS domain. Now, what will happen when the packet will be forwarded through this MPLS domain? Only your label will change. As it will go through a number of LSRs, only your label will change. This will remain same. We don't have nothing to do with this here. We are only concerned here with the labels. So this will be added here between the layer 3 and layer 2, because this MPLS sits between these two layers. Now what will happen? Now it will move to the next LSR. So that will have a label base info. Now it will see that this is 17. Then at next LSR, a new label will be attached like this, 26. So this will be the swapping. It will swap the label here. Then it again forwards. So it will continue until it has to reach the destination. So when it arrives at the egress LER, which is the exit point here, it will pop the label, and then it will forward the packet to the IP domain here. So this is how this MPLS, multi-protocol label switching, will work here, and we can see that it simply have advantage over like your IP, because it is less time consuming and a path is established here, and for every it can support different protocols here. It doesn't depend upon the underlying technology here. So this is a very great technology here for improving the performance of your like telecommunication and other transport networks here. So this was just about the basic introduction of your MPLS. We will study more concepts of MPLS technology in our further sessions. Thank you so much.